So there are two formulas to remember. One is that if your hypothesis test is two-sided, and of course I'll give you this formula so you don't have to remember. N equals to, for two-sided case, it's Z 1 minus alpha over 2 minus Z, no, it's not minus, it's plus, sorry. It's plus Z 1 minus beta divided by effective size. What's this? Okay, and then one-sided is N equals to, it's same as this one, except that because it's one-sided, you don't have to do 1 minus alpha over 2, it's just 1 minus alpha. Okay. And in both cases, effective size is the mu claimed minus mu actual divided by sigma. Okay. All right, so in our case, this is a two-sided test. Therefore, we just have to use this one with effective size. So let's try to say that. Okay, so there's one mean, which is 95. The other mean is 100. Okay? And you want to detect this difference. So what you want to do is you want to do claimed is 95. And it's the claimed value if coffee has no role in the glucose level. Okay? But what they think is that the actual glucose level is slightly higher, and it's 100, okay? And then standard deviation is 9.8. So that's going to be 5 divided by 9.8. Can you tell me what that is? 0.1... 0.510. 510? Yeah, okay, that's right. Okay, so that's what you have. And then 5 level of significance. What does this mean? Alpha equals to 0.05. Yeah. So this is going to be alpha equals to 0.05. Okay. And then 80% probability to detect this difference. What does that mean? That means the power is equal to 0.8, which is 1 minus beta. Okay, so now you're going to calculate each one of them. I already know this value, Z 1 minus alpha over 2. When alpha is 0.05 with two tails, I know that this is 1.96, so we can just use that. What is Z 1 minus alpha, 1 minus beta? Can anyone calculate this for me? Inverse what? Inverse norm of 1 minus beta, which is 0.8. Okay. So what's that? .842. 0.842. Okay. So now we just plug everything into this formula and we're done. So we have n equals to this one, which is 1.96. This other one is 0.842. And ES is 0.510. What did you get? Something like 8 or 9, I think. I'll do it.
30.2.
Oh, it's 30.2?
Yeah.
Oh, that's...
Yeah, 30.2.
Okay. All right. So, what should be the sample size then?
31.
31. Yeah. You can't have 30.2 people. So you have to always round up. So n equals to 31. You don't want to do 30 because then it will be not have the power of 80%. You always want to round up. Okay. So that's the answer. I'll just delete this one. Okay, last question. A farm product manufacturer wants to determine if the yield of a crop is different when soil is treated with different types of fertilizers. 15 similar plots of land are planted with the same type of seed but are fertilized differently. At the end of the growing season, the mean yield from the sample plots is compared. Okay, so what are the experimental units? This would be plots of land. What are the factors? Fertilizers, yeah. Is there any other factor? Is there anti nothing? It's just fertilizers, right? Okay. Levels. So levels are about the factors, different types of factors, right? Yeah, 3 levels, right? Yeah. These are 3 different fertilizers. Okay. What's the response variable? Mean yield. Because that's what it says, right? The mean yield from each sample of plots is compared, okay? How many treatments? Is this a one variable thing? It's a one variable experiment, so if you have one variable, then what's the relationship between levels and treatments? Yeah, same. Yeah. Okay. If you have 2 factors, then all the number of levels should be multiplied, right? Yeah. But here, treatments will be the same. Okay. All right, that's